Here in this design example, a light-emitting diode converts electric current into an optical signal. LEDs, light-emitting diodes, operate at low signal levels with voltages about 1 volt to perhaps 3 volts and at currents between 10 milliamps and 40 milliamps. Voltages or currents above these levels may damage or destroy the device. So in this circuit, we have an LED operating at 1.5 volts. In other words, that's equal to V, shown here, and is connected to a 5-volt source by an interface circuit. We want to design the interface circuit so that the LED current is I, shown here, is equal to 15 milliamps plus or minus 10%. And we want to use one of the or more of the following standard resistors of 110 ohms, 160 ohm, 240 ohm, 360 ohms, and 510 ohms. These resistors all have a tolerance of plus or minus 5%, which must be taken into account in the design. So that's the design example. Again, we need to design an interface circuit so that the LED current is 15 milliamps plus or minus 10%. So let me highlight that. So that's our design goal. Let's say the source, this 5-volt source, is directly connected to the LED. That implies that the current I through the LED is equal to 5 divided by minus 1.5, since this is a 1.5 volt, all that divided by the 2 ohm resistor shown here is equal to 1.75 amps. Now this much current would destroy, or would I say vaporize, the device. Therefore a series resistor, which I'll draw right here, needs to be connected to limit the amount of current going through the LED. So we'll start off with a KVL loop right around here, which will start here, go through the 2 ohm, go through this R resistor, and then go through the LED, and we end up equal to 0. So here we'll end up with minus 5 volts plus 2 plus R, adding this 2 ohm resistor with this interface circuit of just consisting of a series R resistor multiplied by the current I plus the voltage drop V across here is already 1.5 volts, and that's equal to 0. Now this implies that R1, that is equal to 3.5 divided by I minus 2. Now I in this case is equal to 15 milliamps or 0.015 amps. Substituting that value in that equation for R, we have 231 ohms. Now, the nearest standard value listed is shown here to be 240 ohms. With a plus or minus 5% tolerance. That implies 240 minus 5% of 240 is less than or equal R, which is less than or equal to 240 plus 5% of 240, which is equal to 228 less than or equal R less than to equal, these are equal right here, less than or equal to, the upper limit would be 252 ohms. Now substituting the lower limit of 228 for I in this expression is basically 3.5, this expression here. Let me highlight that. So we can calculate I, and we can use this one also. Of 228 plus 2, which is equal to 15.2 milliamps. Now the upper limit is 252 ohms, so the I for that case would just be 3.5 divided by 252 plus 2 is equal to 13.8 milliamps. Both of these values, 15.2 and 13.8 milliamps, are within the 15 milliamps plus or minus 10% tolerance on the LED current.